Here we are again with another video, and this time I'm Mr. Lamb.
I'm still Mrs. Lamb.
And we're going to talk today about what I tried to do before, cross-simplifying when you're multiplying.
Yeah, it's a way of making your problem easier before you actually start it, instead of after.
Ooh, so let's show them.
Okay. Well, first we got to go to our targets.
Okay.
Learning target. I can cross-simplify fractions to lowest terms before I multiply.
Yeah, we're going to make it so that it's easier in the end.
Okay?
And of course,
yeah, you do this one.
I can show evidence of my thinking on paper.
Really important in this cross-simplifying because...
We've said it now about what? This is like the 5th video we've talked about writing it down on paper, so I think we're serious about it.
So let me explain this first slide to you, if you can give me a pen to work with. I have some lines going up and down, and I have a line making a cross. Cross-simplifying is just reducing before you multiply. So I have an example right here of 2/8 times 2/6. And the reason I picked this one, and we would never actually do these because they're not most terms, but the reason I picked it is because we could literally reduce up and down this one, because we know that would be 1/4. And we could reduce this one up and down, and that would be 1/3. Okay. Or, yep. No, Mr. Lamb, I wanted that one. Thank you. Do your cross.
Okay,
so
or we could have done it this way. We could have said, well, 2 goes into 2 one time, and 2 goes into 6 3 times. And 2 goes into 2 one time, and 2 goes into 8 4 times.
So you would have had 1/4 times 1/3.
Oh,
so this one was cross-simplified. This one up here was cross-simplified. This one was simplified up and down. Whoops. I'll do an arrow so you don't think that's a 1, up and down. So they both are 1/12. So that's what it means to cross-simplify. Normally we reduce our fractions up and down, numerator, denominator, but we can look opposite.
Yeah.
Okay?
One way to think about it is anything from the top can reduce with anything from the bottom as long as they share a common factor. It doesn't have to be cross and cross. It could be up and down and then across.
Yeah, there you go.
You can use any combination. I always like to say anything from the top can be reduced with anything from the bottom.
All right, and let's do some examples. Pointing out our first example here. Yep, go to the next screen. We have some that are actually done for you, and we've changed the color so you can see the 3 and the 6 diagonally here is the same as 1/2.
And how did we get that? Well, we divided them both by 3.
And this way, we divided both of these, the 5 and the 15, by 5. 5 goes into 5 one time, 5 goes into 15 3 times. So we simplified it. Now, if we had not simplified it, we would have had 3 times 5, which is, I think I need 10.
Oh, you do.
3 times 5 is?
1 second, give me a second.
15. And 6 times
15 is 90.
Now, when you get all said and done, you're going to get 1/6.
Yeah, but no offense to all of you out there. It's going to take you probably multiple steps to figure out that can be reduced down, because you might go, well, I can divide them both by 3, or I can divide them both by 5, or some of you might even say I can reduce them both by 15. But that's a pretty big number.
It's making the problem simpler before you multiply.
It's really easy to see it here and here, much easier than trying to do it out here. That's why before when Miss Berger yelled at me because I was going to show, ooh, can I show them? Because I like simple. And so when things are easier, that's what I like to do.
All right, we have one more example before we pick a couple of our own. So this one, the reason we picked this example is because the 7 and the 6, there's no way to go up and down to reduce them. I could have reduced the 3/9 or the 3/6. In this example, they chose to reduce the 3/6 to 1/2.
And had they done it this way, it would not change the answer. No. The answer would still be exactly the same.
Exactly, which is what we're going to demonstrate in a minute. So let's go to our demonstration slide, and I have 3 examples. If you'll give me a pen.
I sure will.
I'm going to start. I'll do the writing.
There you go.
All right, we have 2/10 times 3/6. And if you could change colors so that they can see, go for it.
Okay, so again, I can do this one of two ways. I could do it this way and this way. I could do it this way. So I'm going to start out by going, let's
This
just...
is an up and down one.
Okay, so we'll just do this then. We'll go 1/5. And then we can go here. And
3.
and again, I get in trouble sometimes because I do a lot of mental math.
Okay, yeah.
Okay, so what I'm doing here is I'm just dividing them both by 2. Okay, so I really need to explain that sometimes rather than just do it.
Yeah,
Okay, and here I have 3 and 6. They're both divisible by 3. So I'm just going to go 1, 2, because 3 goes into 3 once and 3 goes into 6 twice.
So here's the important, I'm just going to jump in. The reason to cross these out is because they no longer exist. So you have to focus on the new numbers that you have. And go ahead and multiply them.
So 1 times 1, 1. 5 times 2, 10. And that's a terrible 10, but that's okay.
We know we're in lowest terms because 1 and...
Anything,
done.
yeah, done.
1 and done. All right, I have another example.
Okay, let me get rid of that one.
Okay, so I've got 11/15. Ooh,
that's a toughie.
Times 20 33rds.
Hope that blue isn't hard to see. Miss Berger, would you look at that and see if that blue is hard to see? Kind of, so I'll tell you what we're going to do. We'll just go.
Okay. You know, you're right, it probably is.
I just worry sometimes because we really can't tell.
Can you get that?
Oh, wow, check this out. We can do it at the same time. I love it.
I love it. Okay, can you give me a red?
I can.
All right, so what I'd like to do is look at this, and I immediately am drawn to the cross canceling. Okay, up and down, yeah.
You gotta look for things that just are obvious to you.
But that 11 and 33, 11, 22,
33.
33, both divisible by 11. So how many 11s in 11?
1.
1. How many 11s in 33?
3.
3. Now I kind of write mine a little bit off to the side. That's just kind of my way, and I actually do change color pens when I do this.
Oh, you want a different color?
Yes, please.
Let's try
green.
Green.
So 15 and 20 divisible by 5.
Pretty easy
How
to figure that one
many 5s in 15?
3.
3. How many 5s in 20?
4.
4. All right.
Can I point out something real quick?
Sure.
One of the things you need to be careful of, sometimes things can be reduced more than one time, and it's perfectly acceptable to do it. Now this one, it isn't, okay? But you might get one where like, hey, I can divide that by 2. Well, you also could have divided it by 4. So, but if you do 2 twice, it's okay.
It is okay. Now, here is something I do want to point out, but I just totally forgot what it is. So let's just go ahead and multiply.
Okay.
1 times 4 is?
I interrupt
4. That's okay. 3 times 3 is 9. Ooh, I gotta think on this one because 4 is a composite. A composite number. 9 is a composite number, so I do have to think. What did Miss Berger called it? The rainbow.
Yeah, the rainbow. What are the factors of 4?
4. Okay. 1 times 4 and 2 times 2, and that is our rainbow. And 9, not green. 1 times 9, he's changing colors. And 3 times 3. Okay. So I guess the green isn't showing up too well. All right. Well, anyway, the only thing they have in common is the 1.
Yeah, because this one was 1, 2, 2, and 4.
And we have 1, 3, 3, and 9. So this is one of those.
See, we can fix it on the fly.
Composite numbers that are in lowest terms. 4 over 9. All right. No more green. No more green. All right. He's gonna fix them all. Oh my goodness, Mr. Lamb. Anyway, all that work and here's our answer.
4 9 is our answer.
But stop for a second before you erase it. 11/15 times 20 33rds. I mean,
that's a toughie.
That looks pretty tough to begin with, but look how simple.
Yeah, and this is why when we were doing that other video, I wanted so bad to jump in and say, reduce before you multiply. See, I don't even like the word cross simplify. I just like to say reduce before you multiply. Find something on the top and something on the bottom. One more.
All right, and we have
You
a
can do
little.
this. I need this back.
Ooh, you need it back?
You stole it from me.
I did. Okay, give us a nut color.
Let's go with black.
I will write it, and
Ooh, I get to solve it?
You get to solve it, and I'll just stand back and I'll be quiet.
Yeah, I figure those odds. So anyway, I look and I go, okay, well, threes. I know threes. So let me get that red. There we go. So if I divide both of these by 3, I end up with 1 and 3. So now I'm going to look around and see, is there anything else? Well, 4 and 7, they obviously don't share anything. 3 and 4, they don't share anything. And 3 and 1, they're already 1 and 3. So now there's nothing left for me to do, just multiply.
Go for it.
That's 1 times 4 is 4. And 7 times 3, 21.
21. And now we've got to think about, is it in lowest terms?
Well,
4,
actually, you don't have to think about it at all.
well, yeah, you're right.
Yeah, you really
Why?
don't. See, one of the reasons I love this is because if I can't reduce anything here, then I know my answer is in lowest terms.
And we have an even and an odd number. We're good.
But I'm just saying, if you can't reduce here, you can't reduce here.
If you're 100%
Never.
sure. Okay.
Yeah, but she does have a point.
100% sure.
If you left 2 numbers here that could be reduced, you
Yeah.
could catch it here.
Yeah. So we
But
always want to look
that's
for
the
that.
whole point.
All right.
Get them reduced here. All right. Is that
So,
good enough?
That's good enough. We're
Okay,
talking
then let's
too
just
much.
go to the next one.
All right, return to your assignment page and complete those practice for today. Have a great one. Bye.
Bye-bye.